Greetings. Today we are going to discuss about the switching technique in computer network. So as far as switching is concerned, what is the definition of switching? Switching is nothing but the mechanism for exchanging information between different computers, and it will be in terms of segments. Segments is nothing but a portion in which we are using a switches to transfer the data from one network to another network. So the meaning of switches is it helps the system to transfer the information from one network to another network. Right? Here in internet, a switched network in which switch connect at least two links together. What is the meaning of link? We have already discussed. Link is nothing but a path between two hosts. Two hosts is nothing but two end system. So for establishing a communication between the two hosts, we are going to use a switches. And why it is called a switched network? So here there are a number of networks available in an internet, and these internets are, that is these networks which is present in the internet are connected through switches. So that is the reason why internet is a switched network. It is called as a switched network. And here each switch will forward data from one network to another network when it is required. That means when a system which is available in one network wanted to transfer a data to another network, then that time this switch will help us to transfer the data or forward the data from one network to another network. Generally, these switches are classified into two major categories. One is called circuit switching and another one is called as a packet switching. So what is the meaning of circuit switching? A circuit switch network is having a dedicated connection. So what is the meaning of dedicated connection? It is a permanent connection, or we can say that that connection is only for that particular device communication alone. That is the reason why that dedicated connection is called circuit. So it is always available between two end system, always available only for those two system alone. The best example for circuit switch network is our landline connection. So our landline connection is dedicated to our home alone. So the other neighbors cannot able to access our that is landline connection. So it is dedicatedly allocated for our home. That is the best example for circuit switch network. So here the switch can make it either it will be active or inactive state. When there is a communication, there is a call, or we are making a call to other person, then it will be in the active state. Otherwise it will be in an inactive state. When we are not using our telephone, then it is in the state of inactive. So how it is possible to making a system or device as active or inactive with the help of switches? So by using a switch only, we are making a device to be active or inactive. So when there is a call, then the switch will make it as active mode and we are attending the call. Or when we are establishing a call or we are calling to some other person, then the switches will make it the telephone as an active state and we are making a call. And here the very simple switch network that connect four telephones to each end. That is the reason why I told the best example for circuit switch network is our landline connection. So we will see the below figure will show you to understand the circuit switch network in clear manner. Here we are having a circuit switch. So here in this one switch we are having a 4 connection. In other end also we are having a 4 connection. So here the thick line represent, that is here we are having the line is represented in high capacity line and low capacity line. So this thick line represent that this line or this cable is having a capability of forwarding or establishing a 4 connection parallelly at particular period of time. That is simultaneously these 4 devices can establish a communication with these devices. That is the meaning of this high capacity line. So maximum at particular period of time, these all the 4 telephones can able to establish a communication with these four telephones parallelly. So maximum 4 telephone lines can be used. The thick line connecting two switches is a high capacity communication line that can handle 4 voice communication at the same time. The capacity can be shared between all pairs of telephone set. This capacity, high capacity line will be shared by how many number of telephones? Here there are 4 number of telephones can share this capacity. So 4 plus 4, 8 telephones can share this communication medium. The switches used in this example have forwarding task but no storing capabilities. See what that is a disadvantage of circuit switching. So here the switches, what it will do is, whatever the information which is emerging from this telephone, it will forward. It cannot able to store any information at particular period of time. So that is a disadvantage of this circuit switching network. So what is the meaning of low capacity line? So for example, so this is maximum 4 connection is possible simultaneously at particular period of time, but only one connection is using. That is one system, that is this first one telephone is establishing a communication with this telephone. The remaining 3 connection capabilities or capacity will be underutilized. That is the drawback of this one. So what is the meaning of this one is, even though it has a 4 link that can be established parallelly, but particular period of time only one connection is we are using, other 3 will be underutilized or unused. That is a disadvantage, major disadvantage of this circuit switch network, because it is having a dedicated connection. So here there are 2 scenarios in which we can understand very clearly about this circuit switching. So for example, in first scenario, all telephone sets are busy. That means here the 4 that is telephones are making a call to these 4 telephones. So the entire capacity will be fully utilized. There is no problem, right? Parallelly it can make a communication. That is the first scenario. So 4 people at one side are talking with 4 people at the other side. The capacity of thick line is fully used. So there is no problem, maximum capacity we are utilizing. But in the case of second scenario, only one telephone set at one side is connected to a telephone set at other side. So 1/4 of the capacity of thick line is used. That means one capacity we are using, another remaining 3 capacity we are not using. This means that a circuit switch network is efficient only when it is working at full capacity. So why we are saying that it is efficient only at full capacity? If all the systems are used, then we can say that the entire communication channel is used. But if suppose we are using less number of communication, then the remaining will be unused, right? So that is the reason why we are saying that if it is efficient only if it uses the full capacity. Most of the time it is inefficient because it is working at partial capacity. Why we are saying it is a inefficient? Maximum 4 connection is possible, but we are making only 1 connection at particular period of time. So that we are saying that it is underutilized or unutilized for time being. So that is the biggest drawback of circuit switching. There are 2 drawbacks. Now itself we can identify. One is the switches doesn't have any storing capability. It just forward the information which is received and it won't store any information. That is the first drawback. And second drawback is here, if full capacity is not utilized, then it is considered as underutilized, that because it is having a dedicated path. Only if we are not using, for example, we are having a landline connection and 2 months we are going abroad. We are not using, but we are paying, but we are not using. That line is dedicatedly allocated to us. So nobody others, right? Other persons cannot use that one. So that is the drawback of circuit switching network. To overcome this circuit switching network, we are going for packet switching network. So here, why it is called packet switching, we will discuss later on. Here in packet switching network, the communication between 2 ends is done in block of data called packet. See here, for example, I wanted to send a message. A message will be divided into multiple number of packets. What is the meaning of dividing? It is sliced into small packets. The reason because, so if suppose we are sending the information, sending the message as it is to the destination, if any congestion occurs in between, there may be a possibility that the entire message may be dropped. To overcome this problem, we are dividing the entire message into small chunks, or it is called as a slice, or it is also called as a segments. So these segments are called as packets. So we are dividing into, for example, you take a message, that message is divided into 10 packets. So here this 10 packets will be transmitted from source to destination. So instead of making a continuous communication, we will be making this packets to travel in different route. We will see one example so that we can able to understand how these packets will be transmitted from source to destination. So here the advantage of this packet switching network is, the another important advantage is, it is having a storing and forwarding, right? So the each switches which is available in the network can able to store and forward the information to the destination, and each package which we are forwarding is independent entity. Why it is considered as an independent entity, that also we will see with the example. So here a router in a packet switch network has a queue that can store and forward the packet. See here, assume that this is the router. So this router is acting as a switch. So I told these switches will be having a capacity to store the information as far as packet switching is concerned. In circuit switching, the router doesn't have a capability to store. But in the case of packet switching, that is a router or switches will have the capability to store and forward. So why we need this storing facility? For example, here we are forwarding a data from these systems or sender to the receiver. So if all the three, for example, you take these three system is forwarding a data to the router. This router is connected to some other node. Here only one connection is there. So there may be from different network, there may be a connection for the router. So this router is forwarding data through this communication link. If suppose simultaneously you are sending more data, then there may be a possibility that this router will drop all the data. To overcome this problem, we are having a storing capacity or storing capability will be included in the switches. So what it will do is, it will collect all the excess data and it will be storing in the queue. So in the order in which received, the data will be forwarded in the queue. So it will be stored in the queue. So once this router will forward the remaining data which is available with them through this link, then it will take the data from the queue and it will forward, so that the dropping won't occur. So whatever the information which is received or sending by the sender will be stored and it is forwarded through the communication link. That is the advantage of having the packet switching network. And another thing what we have discussed is, it is independent. The packet is an independent entity. What is the meaning of independent entity? Let us assume that this sender, you take this system, this sender wanted to send a message, and before sending that message, the message will be divided into number of, what I told, number of packets. So here let us assume that a message will be divided into 10 packets. So here through this router or to this switches we are forwarding. If suppose this router is already busy, the 10 packets will be stored in the queue. So after forwarding the information which is available in the router, it will take packets from this and it will forward through this link. Let us assume that the first packet, assume this is a first packet. This first packet is extracted by the router and it is forwarding by using a link. And here another important point is, a router will have to reach at the destination. Let us assume that this system wanted to send some information message to this third system. So to reach the third system, it is not necessary there should be only one route should be available. Let us assume from Coimbatore I wanted to reach Chennai. So whether only one route is available? No, it has two different routes. One is we can go via Salem and another route is we can go via Tiruchi. Is it not? So the distance, the kilometer may be different, and it based on the kilometer distance, the cost may be different. That is totally different. What I wanted to tell you is that here the communication between one sender or to the another receiver, there may be multiple number of routes that may exist between the sender and receiver. So here, for example, I am going to send the first packet by using this route. There may be another route. For example, assume this is Coimbatore and this is Chennai. So first packet I am forwarding through Salem, right? And at the time this router is so busy, so that I cannot able to send my second packet by using this route. What I am doing, I am going to send the second packet by using via Trichy to reach at the Chennai. Third packet, at the time while I am trying to send the third packet, this router is free. That time I am sending here. And fourth packet, this is busy, so that I am using Trichy to route Trichy will be used to reach at the destination. Like that, each and every packet will be considered as a independent entity. So it is not necessary for us to send all the 10 packets by using the same route. And this is drawback in circuit switching. So in circuit switching, all the 10 packets has to be transmitted by using only the same line. But here that drawback will be overcome by using a packet switching. So based on the status of the router, if the router is busy, we can use alternate route and to reach at the destination. And why we are saying it is an independent entity. So in each and every packet, along with the message or the data, we will be appending or encapsulating the sender address as well as the receiver address. So that 10 packets are there. In this example, we have taken 10 packets. 10 packets will have the sender address, the receiver address and data. So when it reaches to the receiver, right, here the first packet may arrive first, then third packet will be arrived and second packet will come late. So it may be in any order. The receiver receive the packet in any order. It is not necessary it should be received in a sequential order. It may be received in different order. So 1, 5, 3, 7, 2, like that the 10 packet may arrive. So in any order it can receive the packet. After receiving that, what it has to do is it has to reassemble. What is the meaning of reassemble? Here reassemble in the sense that it has to wait until all the 10 packets has to be received, and then it has to make a sorted order, and then it has to be handed over to the end system. So that is also another advantage. That is the reason why we are saying that it is a independent entity. The packets are considered as a independent entity. There are two advantages. One is the router is having a capability to store and forward with the help of queue, and second one is the data will be divided into slices, that is nothing but a packet, and these packets will be considered as an independent packet because it will be following a different route to reach at the destination. These are the two advantages of packet switching over circuit switching. So here now assume the capacity of thick line is only twice the capacity of the data line connecting the computers to the routers. Why we are saying the twice the capacity? Sender and receiver. So both is available, so that it is having a only twice the capacity of the data. If only two computers need to communicate with each other, there is no waiting for the packet. So let us assume that only these two system wanted to establish a communication with these two, and these two are not utilizing. So in that case, without any delay, the data will be forwarded from these two system to these two system. So here, even though we are underutilizing, but the data will be transmitted to the destination in a faster manner. And here if packet arrive at one router and the thick line is already working at its full capacity, the packet should be stored and forwarded in the order they arrive. That is the reason why I told the router is busy, but this system is sending data. Busy in the sense already it is having working with full capacity. So that means already 4 connections are there and it is forwarding data. Further and further the system is sending a data means then it will store the information in the queue, and after completing the previous task it will extract the data or extract the packet and it will forward, and that is the meaning of store and forward. And here we have shown the simple example for packet switch network, more efficient than circuit switch. In two way it is very best packet switching. One is store and forward and another one is slicing a data into packet to make the packet to travel as an independent entity. But the drawback in packet switching network is we may encounter a delay. How it is possible delay? So for example, if already this router is busy, it is working in full capacity, further and further this machine is sending a data, then what will happen? It will store in the queue, right? And then after sending all the data which is available in the router, then only it can extract the data from the queue and it will forward. That is the reason why the delay may occur. But in previous case, if the full capacity is used, like that is previous case in the sense in circuit switching, if the full capacity is in the using state, then what will happen? If further and further data is passed by using this system, then that data will be dropped, right? It won't accept the data. So whatever the data which is forwarding by the system, it will be dropped here because it doesn't have any storing capability. But in the case of packet switching, it will have the storing capacity so that it will store and then later on it will forward. So dropping will be more danger than delaying. So if we can delay the data to travel from one system to another system, but dropping is again we have to send the data once again, more number of time we wanted to send the data. So that is the disadvantage of circuit switching compared to packet switching network. So delay may be there, little bit delay may be there, but it will transfer the data from source to destination even though it is in the full capacity. So that these are the two advantages of having a packet switching compared to circuit switching network. So these are the simple comparison between the circuit and packet switching. So here it is a connection oriented. So why we are saying it is a connection oriented? There is a cable that has been established between the sender and receiver. That is the meaning of dedicated path. That is the reason why we are saying it is a connection oriented. And as far as packet switching is concerned, the best example is mobile communication. Is it not? So our mobile is establishing a communication with the base station in a wireless mode. So for example, there is one tower. Is it not? That tower, with the tower maximum 100 users can establish. So all the 100 users are sharing that communication medium. Here in this case only one user. That is I told as far as circuit switching is concerned, always you remember the landline communication is the best example for circuit switching. So a dedicated path will be given. Whether you are using or not, it will be dedicatedly given to you. So nobody else can utilize. But in the case of mobile communication, if one user is not using, some other user is going to use. How? By means of connectionless network services. So best example for packet switching is, here you can say that mobile communication is coming under packet switching network. And here a dedicated path has to be established between source and destination before transfer of data commences. Once the data is transmitted, the path is relinquished. So disconnection will take place. Once data communication is over, the dedicated path will be in inactive state. But there is no need to establish a dedicated path from source to destination. There is no dedicated path as far as packet switching is concerned. That is the reason why I told the best example is going to Chennai by using the first packet is following one route, second packet is following different route. There is no dedicated path between Coimbatore to Chennai. So we can use either the Salem route or by using a Trichy route we can reach at the destination. So there is no dedicated path in the case of packet switching network. So it is inflexible in nature since data packets are routed along the same dedicated path. I already told in circuit switch network, if I am going to send 10 packet, all the 10 packet has to follow the same route to reach at the destination. Here each packet is routed separately. So consequently it is flexible in nature. If one route is busy, we can use another route to reach at the destination. That is the advantage of having packet switch network. It was initially designed for voice communication, but packet switching is specially designed for data transfer purpose. The entire message is received the order in which sent by the source. So because all the packets has to be travel in dedicated line. So we are sending a first packet, second packet, third packet, like the same order it will be received by the receiver. So that is the reason why the entire message will be received by the receiver in order. So 1, 2, 3 like that. The continuous order it will be received. But here in the case of packet switch network, each and every packet will be considered as an individual entity and it can follow a different route to reach at the destination. So that in the destination mission, so what it will do is it will collect all the packet and it has to reassemble. What is the meaning of reassemble? I already told. It is nothing but sorting the packet. All the packet has to be received at the destination. After receiving all the packet, it has to be sorted and then only it will be handed over to the end machine or end system. So this circuit switching is implemented in physical layer. Why we are saying that it is a physical layer? A dedicated path. That is nothing but the cable has to be established between the sender and receiver. So that is the reason why it is available in physical layer, but it is implemented in network layer. So we don't have any communication in a physical layer. It is providing in connectionless service, so that it will be implemented in network layer. It has two approaches. As far as circuit switching is concerned, it has two approaches. One is space division switching and time division switching. So here based on the area, the spatial area, we are going to communicate the information. We don't bother about when this data will be delivered at the destination. There may be a delay because we don't have any store and forward mechanism. And time division switching is this packet has to reach at the destination at particular time. So if that is not received at particular time, that packet will not be accepted by the receiver. So as far as packet switching is concerned, it has two approaches. One is called datagram and another one is called as a virtual circuit. So datagram is nothing but each packets, right? The messages are divided into so many number of packets. The message is represented as a datagram and each packets will be traveling through independently. And virtual circuit is we do not know, that is user doesn't know by using which route the packets are forwarded. So virtually we are thinking that we are using the particular route, but actually it is not happen. It may use a different route to reach at the destination. The user doesn't know which packet is traveling which route. That is the reason why it is called as a virtual circuit. So it is not store and forward transmission. So I already told that is one of the biggest drawback of circuit switching. It doesn't have the capability to store and forward. But in the packet switching network, it has a store and forward mechanism. So data is processed and transmitted at the source only. What is the meaning of data is processed at the source only? So here, since the routers or the switches which is available in between doesn't have a storing capability, the source has to initiate the sending process and the destination has to receive. So here the source is responsible for forwarding any data. But here in the case of packet switch network, data is processed and transmitted not only at the source but on each switching station. So for example, why we are saying like that? Here there may be, in this example, there may be one switch. But in a larger network, you may be having multiple number of switches. So here this machine wanted to send some information to this machine, means assume that there are 5 switches are there between these two systems. So it will forward information to the first switch, and after that this switch will forward to second will forward to third, and how it will forward, it will store and forward. If that router is busy or that switch is busy, it will store the information which emerged from the previous router and then it will forward. So here that is in the case of packet switch network. Here the data will be processed not only by the source but also the each switching station which is available in between source and destination. So these are the basic difference between circuit switching and packet switching. So what we have discussed in this video lecture, we have discussed what is switching and why we need switches, what is the responsibility of the switches, and what are the two different mechanisms will be available under switching. One is a circuit switching and another one is a packet switching. What is the drawback of circuit switching? So drawback is, one is a dedicated path is needed, and second one is it doesn't have any store and forward capability. But as far as packet switching is concerned, we don't have any dedicated path and we'll be having a store and forward capability. So these are the things we have discussed in this video lecture. Thank you.